Hello students, here in this video the revision third unit, that is sensors and transducers. Here the introduction and definition of sensors and transducers. The term sensor is used for an element which produces a signal relating to the quantity being measured. This is the case of, say, an electrical resistance temperature element. The quantity being measured in temperature and the sensor transforms an input of temperature into a change in resistance. The term transducer is often used in place of the term sensors. The transducers are defined as elements that, when the subject to some physical change experienced a related change. Next question, list performance terminologies of sensors. Here, first one, range and span. Here the range of a transducer defines the limits between which inputs can vary. The span is the maximum value of the input minus the maximum value. Thus, for example, a load cell for the measurement of forces might have a range of 0 to 50 kilonewton and a span of 50 kilonewton. Next one, error. Error is the difference between the result of the measurement and the true of the quantity being measured. That is, error is equal to measured value minus true value. Next one, accuracy. Accuracy is the extent to which the value indicated by a measurement system might be wrong. It is thus the summation of all the possible errors that are likely to occur, as well as the accuracy to which the transducer has been calibrated. For example, a temperature measuring instrument might be specified as having an accuracy of plus or minus 2 degrees Celsius. Next one, sensitivity. The sensitivity is the relationship indicating how much output you get per input, that is, output divided by input. For example, a resistance thermometer may have a sensitivity of 0.5 ohm per degree Celsius. Next one, hysteresis error. Here, the hysteresis error transducers can give different outputs from the same value of quantity being measured according to whether that values has been reached by continuously increasingly change or a continuously decreasing change. This effect is called hysteresis. In this figure shows such an output with the hysteresis error as the maximum difference in output for increasing the decreasing values. Here, non-linearity error using. There are three range of graphs: n range values, best straight line for all values, best straight line through 0 point. For many transducers, a linear relationship between the input and output is assumed over the working range, that is a graph of output plotted against input is assumed to give a straight line. The error is defined as the maximum difference from the straight line. Various methods are used for numerical expression of the non-linearity errors. The difference occurs in determining the straight line relationship against which the error is specified. First graph n range values. One method is to draw the straight line joining the output values at the end points of the range. Second graph, another is to find the straight line by using the method of least squares to determine the best fit line when all data values are considered equally likely to be in error. Third one, another is to find the straight line by using the method of least squares to determine the best fit line which passes through the 0 point. That is the non-linearity errors. Next one, they explain pneumatic sensors. Here in this diagram, the pneumatic sensors, the main components are here. The components are dragged out the port and so drops in the system pressure. Here in this arrow mark, that is escaping air, and inside the low pressure air inlet. Here the one object is there, the applied on the air pressure, okay, rise in pressure and low pressure are inlet. That is the diagram. Here the pneumatic sensor involves the use of compressed air, displacement or the proximity of an object being transformed into a change in air pressure. Low pressure air is allowed to escape through a part in the front of the sensors. This escaping air in the absence of any close by object escapes, and in doing so also reduces the pressure in the nearby sensor's output port. However, if there is a close by object, the air cannot so readily escape, and the result is the pressure increases in the sensor output port. Next one, the explanation of bimetallic thermostat strips. Here the temperature measuring. The main components are high expensivity material, low expensivity material, bimetallic strips, that is soft iron, small magnet, set temperature adjustment, that is the main components. Here his device consists of two different metal strips bonded together. The metals have different coefficients of expansion, and when the temperature changes, the composite strips bends into a curve. This deformation may be used as a temperature control switches, as in the simple thermostat, which was commonly used with domestic heating system, that is bimetallic thermostat strip. Next one diagram, make use of sketch and explain strain gauge load cell. Here the load cell strain gauge is applied on force. The arrangement is generally referred to as a load cell. In figure is a cylindrical tube to which strain gauges have been attached. When forces are applied to the cylinder to compress it, then the strain gauges give resistance change, which is a measure of the strain and hence the applied forces. Since temperature also produces a resistance change, the signal conditioning circuit used has to be able to eliminate the effects due to temperature. Typically, such load cells are used for forces up to 10 meganewton, non-linearity error about plus or minus 0.03. This is a unit. Thank you one and all.